Oh, so I wanted to talk quickly about a point that Cy brought up before the lunch break, which I think is actually really important, and it really does help combine several lines of knowledge together to come to a little better understanding. So I just kind of drew this little diagram for you guys here. So remember we talked about the refractory period? We said that the refractory period primarily occurs when?
During repolarization.
During repolarization, right? Okay, so if we look at the cardiac action potential here, okay, that's what I have drawn here, and then I have the PQRST complex, we would say that the refractory period begins, okay, looking at the action potential, begins, phase one, in phase one, as potassium begins entering the cell, right? And that's actually where we start having a repolarization, right? And by phase three, we're in the absolute refractory period, right? Where it's all potassium moving out of the cell as we move back down to baseline there, right? And that would roughly correspond to, right, here's my R wave. From the R wave to the end of the T wave, this area right here would roughly correspond to the refractory period on the action potential. You guys okay there?
Yep.
That kind of makes sense. And so Cy asked me a question. He said, hey, if I give a drug, I believe the example he used, and that's the example I use here, let's say I give a class 3 antidysrhythmic. Well, what is a class 3 antidysrhythmic going to do? Well, what I've done is I've drawn several action potentials here, and I'm just using non-nodal tissues as our prototype for the action potential. And in black here, this is our normal action potential. And then in red, this is the class 1A. And then in purple here is class 1B. And then brown is class 1C. And then green here is class 3. And so each of these block different ion channels, right? The class 1s block which ion channels? Sodium channel blockers, right? And they all block different sodium channels, fast sodium, slow sodium, etc. But if I look at the class 1A, what do you notice is very different in the 1A versus the normal here in black? What is the most different, what is the biggest change that you see or difference between these? So this is the red one here versus the black one.
The sodium is gradual, not
yeah.
immediately.
So the slope of phase 0 is very shallow compared to the slope of phase 0 in the normal, right? And that would make sense because what is occurring in phase 0? Sodium is rushing into the cell. So sodium is rushing into the cell slowly. So what's the net effect? The net effect is it takes longer to depolarize, right? All right? And so you see that the action potential is longer, it's widened, right, to reflect the increased amount of time that we spend depolarizing. You guys okay with that? But what I really want to do is I really want to point out this class 3 here. And again, where is one of the primary areas class 3 antidysrhythmics work? They do have some calcium channel blocking activity, some beta blocking, and some limited sodium channel blocking action. But where is one of their primary mechanisms?
Potassium?
Huh?
Potassium?
Potassium, right? And so where in the action potential will be impacted if I'm blocking potassium? Primarily repolarization. And so here, do you see the slope of phase 3 and how shallow it is compared to the slope of phase 3?
Which it'll widen out your
exactly.
ST.
It's going to widen this out, but it's going to widen it out in a very special way, right? So here I have a picture of my normal action potential in a normal PQRST complex. And what I've done is I plotted out the QT interval from the Q wave to the end of the T wave. So here's the QT interval on my normal, and then I'm going to administer a class 3 antidysrhythmic, right, and see how the slope of phase 3 has shallowed out, which has prolonged the duration of this action potential. But here's the question. Is it depolarization or repolarization that has prolonged?
Repolarization.
Repolarization. So if I look here at my QT interval, what has happened to the QT interval? The QT interval has
Stretched out.
gotten larger, and I am spending more time in the
T wave.
T wave, the refractory period, right? So the effective amount of time that my heart is in the refractory period increases. And so that increases the chance of what occurring?
The RMT.
RONT phenomena, which increases the chance that I will develop a life-threatening ventricular dysrhythmia like VTAC or VFib. And so that understanding a little bit of the basic electrophysiology can help us understand some of the significant side effects that we see when we administer drugs that impact the action potential.
And which drug was that that Sy had mentioned?
So class 3 would be what?
A calcium or a
No.
potassium?
Potassium channel blocker.
Right, but what would be the drug, the classic, the prototypical class 3 antidysrhythmic agent that we run into? Come on, guys. Just finished pharmacology. You've got to know this. I mean, this is like, this is critical foundational knowledge to knowing this specific medication.
Hypocalcemia. So I'm a magnum.
No, what is the classic class 3 antidysrhythmic?
Dennis.
Okay, so,
Well, that's probably something that you guys are going to need to spend some time studying over this weekend. And I've uploaded an entire cardiovascular pharmacology playlist into this section for you guys. It might not hurt to go through those videos, right?
Amiodarone.
Amiodarone, yes. Okay, you should be able, at this point, if I say class 1A, you should be able to go, oh, propanamide, right? If I say class 1B, you should be able to go, oh, lidocaine, right? If I say class 3, you should go, oh, that's amiodarone, right? These are things that you guys should know. Why should you know? Because of this, right? These drugs are incredibly pro-dysrhythmic. They're incredibly good at causing dysrhythmias, right? And again, to go back and emphasize, before we administer an antidysrhythmic, we need to ponder, right? We need to be very cautious about administering antidysrhythmics because the side effects are so severe. Okay,